Okay, so the goal for today is I'll be able to find the intersection point of two lines. This is done a little earlier in the textbook, but I wait till now to do it. Just because you have more skills, it'll make a little more sense. So linear systems is what this is called. System means we have more than one line to work with, and this leads into, this is just an intro to a grade 10 topic. You'll spend a lot more time on this in grade 10. But we're going to introduce the idea just so you can kind of see where this goes. So quick reminder, y equals mx plus b right here. This is one of our most useful forms of a linear equation where m is the slope and b is the y-intercept. Okay, so find the slope and y-intercept for the following. So we have a slope here of negative 3 over 1, and that comes from that value, and our y-intercept is 0, 8, and that comes from the n value. And again, that's only when it's in the form y equals mx plus b, but we're going to take advantage of that. Okay, so graph both sets of lines on the provided grid, determine where they intersect, and we're going to call that intersection a POI, or a point of intersection. Use graphing technology to verify the point of intersection, so if you want to fire up Desmos, you can check it that way. But let's do this by hand first. So when I look at the first one, I want to write the slope. Now there's no number written in front of that x, but there's a 1 there. Okay, it's an unwritten 1. So it has a slope of 1 over 1, and it has a y-intercept of 0, negative 2. So if I plot that information, there's the negative 2. Now if I go up 1 over 1, and I just draw a whole bunch of dots and graph that line. Okay, then I'm going to go to the second equation, change color. My slope is negative 3 over 1, and my y-intercept is 0, 10. Okay, so I'm going to start at 10, so 2, 4, 6, 8, 10 should be the very top. Now down 3, right 1, because this is negative slope. And you can see right there, those two lines cross at that location. They have a shared point. So now if we look at that, the point of intersection there, if we count, that's 1, 2, 3 over, up 1 is 3, 1. So our point of intersection is 3, 1. And what's really important or special about this POI, this point of intersection, is that 3, 1 is a solution to both equations. Okay, it's the only one. So these two lines have one shared solution, and in this case it's 3, 1. So if you put 3, 1 back up into your original, okay, you'd see it makes a true statement, and you can do that for both of them. So the point of intersection is really important because it's the shared or common solution to both lines, and it's the only one. Okay, so again, graph both lines. Okay, so now it's a little bit mixed up. We may have to do a little bit of work to start here. So y plus 3x equals 7. So I need to do some work first. I'm going to subtract 3x from both sides, and then I'm going to write my slope. So it's negative 3 over 1, and my y-intercept is 0, 7. So if I draw that onto 4, 6, 7, down 3, right 1, down 3, right 1. Okay, and I'm just going to draw them relatively quickly. Okay, and then I'm going to look at the next question. Again, need to do a little bit of work before I can actually draw it. So I'm going to subtract 3 from both sides, get my slope of 2 over 1, my y-intercept of 0, negative 3, put a dot, up 2 over 1, up 2 over 1. Okay, I found the location. So their shared or common location is right there, and that is a POI of 2, 1. So again, our point of intersection, POI, is 2, 1, and that's the shared location. Okay, now this one, okay, this has something a little different in it. The first part is not so bad. Okay, we've seen a lot of these. So my slope is negative 2 over 1. Y-intercept is 0, 3. So if I plot that, 0, 3. Now it's negative, so I'm down 2 over 1, down 2 over 1. I'll fill in a couple going the other direction. So there's my equation, or my blue line, or the first line. Now this one here gets people. Okay, so there's a couple ways you can write this. This is 0x plus 7. That's one way. Okay, the other way is y equals 7. every single point has a y value of 7. Okay, so if you look at your graph, 2, 4, 6, 7. Every single point on this line has a y value of 7. It doesn't matter what the x value is. Okay, but every single point has a y value of 7. And what we'll start to see is that this is a horizontal line. Okay, it has a slope of 0, so if you think of that as 0 over 1, it's going up 0 and right 1. Well, this line here is going up 0 and right 1 every single time. It has a point of intersection right here. Okay, so our point of intersection is -2, 7. Okay, and now just for filling in sake and for conversation, if I wanted a vertical line would have a slightly different expression. A vertical line would look like this: x equals 5. And that means that every point on that line has an x value of 5. So 1, 2, 3, 4, 5. So every single point on this line has an x value of 5. Now that has nothing to do with the question we were working on. It's just a quick reminder that horizontal and vertical equations look a little different, and we have to be aware of them. Okay, so a couple questions to try. I suggest you try using Desmos for some of these, or if you have other graphing technology, put it into action and get used to using it. And thanks for tuning in.